Hi class, let's talk about random numbers in Python. To use random numbers, we will use a library. We will import random, and that gives us access to all of the various methods and tools we need. Now, random numbers in computer science are not really all that random. That is probably not a surprise because random numbers will rely on long algorithms, for example, to generate these numbers. The problem is that those long expressions to generate the random numbers, all of the operands never change. They're the same code every time. So generally in computer science, when you run code thinking that you want a random number, you're really just running the same code that you've always run, and you'll always tend to get the same random numbers. Well, the way we get around this is that those long expressions will use a seed value. And a seed value is just some little offset that we can plant in there that will change every time the function is called. And what typically is used for the seed value is the system clock. Every computer has got a system clock, and that clock is counting the number of milliseconds since January 1st, 1970, and it changes 1,000 times a second. So most programming languages will have options to use the system clock as the seed value, and this will then open the door and pave the way for us getting pseudo-random numbers. And Python is just like in C++. We've got to rely on these pseudo-random numbers using seed values. Now, if you're a C++ coder, you know that we had to set the seed manually to use the system clock. Fortunately, in Python, it does it automatically. So all we have to do is import random, and anytime we use one of the random number generating functions, it's always going to use the system clock. So what are those functions that we'll use here? Well, we'll generally use these three. There are more, but these are the core ones. Randint is simply going to generate a random integer between the values a and b, and these are inclusive. Random.random, oh, let me put the library name there, random.random. And I know it sure kind of looks weird with the same name for the both the class, library, and the function, but that's just the way it is. This will generate a random float between 0 and 1. And then .uniform will give you a float that's between A and B. So I've got some sample code. We'll go over that, and hopefully this will help explain random numbers. Let me go back over to Jupyter Notebook now. And here's our notebook on random numbers. And you'll want to follow along with this notebook, download it and get it up and running to go along with this video. So you can pause the video and play around. All right, well, the first thing that we're going to check out is how can we get code that is in just simply the range 1 through 10, and it's going to return an integer. And as we just wrote on the whiteboard, there's our code right there. We'll just do random.randint. We give it the high and the low parameters, 1 and 10. And remember that this is inclusive. So the random number set will include 1 through 10. It's not going to stop at 10 and only include 9. And since this is a function, we are receiving a number back from the function. We're actually receiving the random number itself. And as part of value returning functions, we have to then assign that to a variable. So we assign it to a variable number, and then we just simply output the number. Now, when we run this each time, you can see that I'm getting different results. There's a 5, there's a 3. And we are getting these pseudo-random numbers, again, because the system clock is being used for the seed value, and that's guaranteeing then these pseudo-random numbers. Now, this next snippet of code here is going to just generate 5 random numbers in a loop. So here's our for loop, and we're doing the exact same thing that we did before. We're going to both generate the random number and then output it. This next snippet of code is going to compact the for loop a little bit. Rather than creating a local variable inside that for loop that was called number, well, we can just simply generate the random number and output it. So that's what this does. It compacts our code a little bit. If I scroll back up here, you'll see that, well, this created a variable called number, and then we output that number. But we can get rid of the variable simply by taking that out, putting that in there, and getting rid of this. And then we have the same code as this now down here, okay? Now this next cell is going to generate 100 random numbers, and we're in the range 1 to 1,000, and we're going to output it in a nice, beautifully formatted 10 by 10 table. So my goodness, how do we do that? Well, here's the code. We've got our for loop that's running 100 times. Every time in the for loop here, we're just printing out a random number. I'm calling randint, and there's the range 1 through 1,000. And I'm just putting that in an F string. So here's the complete F string for the print statement. And we put the variables, of course, in braces, and I'm going to set a column width here, a field width of 6. So every one of those random integers will get printed out in a field of 6. So that is going to line everything up wonderfully. We will have to suppress the n-line character here because we want the tables to output row or element after element and go 10 times across without printing carriage returns. It's only after every 10 that we need a carriage return. So that's what this code does right here. It uses the modulus operator, and it's saying, okay, if the count is currently evenly divisible by 10, well, then I'm going to print out just a carriage return here. That's what that does. It just prints out the carriage return. And note here that I did offset count by 1, just so we get the numbers to line up. Since we start counting at 0, 0 modded by 10 is 0, and our table would start with the carriage return, and we don't want that. So offset that by 1 to get the behavior that we need. And then you can see this gloriously formatted table here. All right, next we're going to use the uniform function, and this is going to return floats. If we want to return an integer, we use randint, of course. If we want to return floats, well, we've got an option of either using random.random or random.uniform. Random.random bounds the floats between 0 and 1, and random.uniform will bound them by a min and a max that you provide. So here I am saying, give me random floats between 1 and 100, and let's get 5 of them. So you see, when we output this, then we got all of these floats with a lot of precision, a very fair amount of precision as well. And those would probably meet whatever need we would need it to meet. Now here's sort of the same thing, except we want those random values to be between 0 and 1. So maybe we need those for some calculation, or maybe an offset, or maybe we're going to randomly scale something bigger or smaller. That's what we could use this for. And that's just going to then be generated by random.random. Pretty funny looking function call there, but that's what it is. Now, this next block of code is, it's from the book. This is the dice simulating code. So let's take a look at it. First, here's the main function. This code here is just if we want to roll again. And all we're doing here is printing out a couple of rolls of the dice. So the two values, of course, we set a min and a max for 1 and 6 because there's 6 faces to a die. And we're just going to output then, what the 2 dice were that we rolled. So here's just simple output. It rolled a 4 and a 6. So we can take this code and then take it up a level and say, okay, well, what the total was 10. Maybe we could figure out, well, what's the distribution of numbers. When we get to lists pretty soon, we'll get to play with that quite a bit. And but meanwhile, there's just simply outputting and letting us repeat the program again if we want. And then our last snippet of code here is just a coin toss simulator. All right, we've got some constants here for if heads is a 1 or a 2, so it's declaring heads as a 1. What we're going to do is a for loop going tosses time, so that's 10 times. And here we're just random.randint is going to go ahead and generate that random number. And it's going to do it between 1 and 2. And since it's an integer, it's going to be a whole number. So it's either going to be 1 or 2. And this is saying if it's a 1, well, then print heads, otherwise print tails. And there's some output that we get there showing the heads and the tails. So I hope this helped just kind of explain random number use and give a couple of good examples. And we'll be using random numbers actually quite a bit in our coding in future assignments. So make sure you get these down and understand the 3 main types of generating random numbers.